Welcome. IMTRA is thrilled to introduce Sleipner's new eVision electric stabilizers to complement their legendary hydraulic vector fin stabilizer systems. While others with their conventional straight fins came to market earlier, Sleipner spent a great deal of time and effort addressing several challenges: how to hold high torque over time, how to match the safety and reliability of hydraulic actuators, and how to avoid noise transfer through the hull. The curved shape of Sleipner's vector fins allows them to be angled into the direction of the water flow underway, thus developing lift to offset drag. The result is virtually no loss of speed compared to flat fins. With electric actuators, it's a much greater challenge, one that Sleipner has met with the combination of a high-torque motor and a strain wave gearbox. It's a remarkably safe and reliable system that complements the next generation vector fins, taking a great idea and making it even better. Another challenge was to reduce noise transfer through the hull. Since the motors in electric fins are located in the actuator itself, unlike the hydraulic stabilizer systems which use ultra-quiet hydraulic cylinders on the actuators, Sleipner has been able to isolate about 90% of the noise and prevent it from resonating through the hull. This is particularly important at night when engines and other noise sources on motor yachts are shut down. There's also an electric brake to lock the fins when not in use, and of course a reduction gearbox. The high-torque actuator allows us to hold the fin at an angle to the water to develop lift, which, as we said, virtually eliminates any loss of speed or increase in fuel consumption due to having the appendages in the water. Conventional flat fins can't offer this speed-saving feature, and thus necessarily reduce boat speed and increase fuel consumption. In order to hold the fins at an angle to the water flow and thus achieve the desired lift, Sleipner incorporates the high-torque motor and a clever, reliable strain wave gearbox. The Harmonic Drive Company has a video that can show you more about this remarkable device. You can find a link to this video in the description below. Harmonic Drive strain wave gears are ingeniously simple and incredibly reliable, used for the Mars rover and on Airbus aircraft, precision robotics, and other applications where reliability must be of the highest order. Failure is not an option. With only 3 components, ratios from 30:1 to 320:1 can be achieved in one stage. Other systems require multiple gear sets to achieve the necessary reduction ratio with many moving parts. In terms of service, the first service requirement is to change the gear oil after 2 years. This can be done from the inside of the boat, so no haul out is required. Aside from this biannual service, the fins should be inspected and painted whenever the hull is painted. Seals should be replaced about every 10 years. Harmonic drive gears come with superb positioning accuracy. As we said earlier, the motor is in the actuator itself, so isolating that noise from the hull is really important at night. Only Sleipner actuators offer this noise isolation feature. This is a video of the boat show display in IMTRA's back parking lot. Admittedly, the display has a more aggressive hull dead-rise angle than most boats, but nevertheless you can see how the aggressive curve of the third-generation vector fin will direct the stabilizing force much more vertically than the top section of the fin. The stabilizing force of the top section is like that of an entire conventional flat fin, which is more outward than upward. The force direction is the crux of the matter. The more vertical, the better. You can also appreciate how the fins slice through the water for a smoother, softer ride due to their shape. And it takes less actuator energy to slice through the water than conventional flat fins. Sleipner started making conventional flat fin stabilizers around 2011, but quickly realized the drawbacks of straight fins. It's inefficient stabilizing force direction, and they produce a certain amount of sway and yaw. Since the whole idea of stabilization is to make guests comfortable and minimize, if not eliminate, seasickness, reducing roll and, as importantly, sway and yaw is critical for your inner ear senses. The answer to these unwanted side effects was the invention of the patented curved vector fins, which reduced the incidence of sway and yaw almost 50%. The new third generation electric stabilizer fins take it to the next level. The new fins direct the stabilizing force in a much more vertical direction. The results are truly impressive when compared to conventional straight fins. It's basic physics. Achieving the sorts of results you see here when in at anchor mode, aka 0 speed, is the hard part. Underway, when you're using the power of lift from water flowing over the fins, the results are simply rock solid. The curved vector fins have the added benefit of providing a more cushioned ride as the fins are acting like foils, and the lift from the fins offsets drag, so there's virtually no loss of speed or fuel efficiency. It's quite a remarkable piece of engineering. Here are the fins in action in at anchor mode on Sleipner's test boat. Note the long sweep angle of about 130 degrees. The fins extend almost 90 degrees out from the hull. Sweep range provides more stabilizing power for a longer period of time. Flat fins can't do this because the outer range ends up paddling the boat rather than stabilizing it. The combination of fin design and sweep angle prevents anchor walk. How much power do you need to run them? The smaller actuator sizes, appropriate for yachts between about 45 and 80 feet, run off DC battery power. The larger ones run on AC power. Underway, the stabilizers use very little power since they only move a few degrees. The faster the boat speed, the more powerful the stabilizers become, so the less they have to move. It's one of the major benefits of fins over gyros, which only have a fixed amount of power. In at anchor mode, or trawling speeds, they necessarily use more power. They have to move through a greater angle. It's easy to state the maximum power you need, but unless you're station holding or at anchor in the middle of the ocean in very large swells, sizing a battery pack for maximum consumption is unnecessary. As you can see from this chart, showing power consumption in at anchor mode, one must take a realistic view of expectations. This includes typical sea conditions one would anchor in and how long you expect not to have a generator running for the battery charger. Battery capacity can then be calculated. Another benefit of the Sleipner patented vector fins and electric actuators is that they consume less power than any other system when comparing the same fin size. Sleipner was not the first to develop electric stabilizers, but their new electric vector fin stabilizers are taking the boating world by storm, following in the footsteps of the market-leading hydraulic vector fin system. The DC systems are pretty simple. The two actuators are connected to the DC power source. They communicate with the SCU, the stabilizer control unit, and then to the touchscreen control at the helm. There's also the option to operate through the boat's MFD. All cables, except battery cables, are prefabricated plug-and-play. The system automatically transitions between at anchor mode and cruising modes. You simply turn them on by touching the screen, and that's it. The system also allows you to select dynamic positioning mode, as well as a docking mode. The docking mode is used if you choose to have your stabilizers run at the dock. The docking mode restricts the outboard sweep of the fins. And there's also a feature to reduce power mode at night, reducing the power consumption by about 30%. There are 6 actuator sizes for boats ranging from 45 to 150 feet, with fins to match the characteristics of the vessel. Larger yachts may choose to use a 4-fin system. Please contact your local Sleipner dealer or IMTRA for more information. We look forward to talking with you.